Hello. Today we're going to talk about scientific notation, and we're just going to introduce how to write numbers in scientific notation and how to write numbers that are in scientific notation back into standard form. So before we begin, let's just talk about the notations that we've learned. So you have learned standard notation, and standard notation is when you take a number and you just write it as you would. So 125, that would be in standard notation. If you think back to elementary school, you learned expanded notation. And that would be when you take it by place value. So 100, 2 tens is 20, and 5 ones is 5. And then word notation is just what it says. You write it out 125. So we're going to learn today, we're going to learn scientific notation. And we're going to be taking numbers that are in standard notation like 125, and we're going to write them in scientific notation, which would be 1.25 times 10 to the second. You might have seen that before. And then we're going to take numbers that are in scientific notation and write them back in standard form. So we're going to go back between the two today. So let's talk about scientific notation and why. So the common cold virus is 0.0000003 centimeters in diameter. Bacteria is approximately 5 times as large as a virus. How large is bacteria? So if you were doing calculations with these really small numbers, you would take 0.0000003 and times it by 5. So just 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you would do 5 times 3 is 15. Carry the 1 would be 5. And then 0. That one would be 0. That one would be 0. That one would be 0, 0, 0.0. And as you can see, the problem here is that you can make a mistake with all those zeros. So scientific notation helps us do the math without having to worry about all those extra zeros. So when you're dealing with very large, so we're talking very large numbers or very small numbers. So we're not talking like 125. It is helpful to write them in a shorter form. That's what scientific notation is. It's just a way of writing a number in a shorter form. So when we write in scientific notation, the number has to be between 1 and 10. So when you think of it, it has to be a single digit. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Actually, that probably should say 0 and 10. So it has to be a number that is it's a whole number. So we could even add that in there, a whole number. And then you write it times 10 to some exponent. So we're going to talk about why and how we get that exponent. So again, it's a whole number between really 0 and 10, 1 and 10, including 1, times 10 to an exponent. So here is a really big number. This is the mass of the Earth mass of the Earth. We want to write it in scientific notation because heaven knows we don't want to worry about all those zeros. So what we're going to do is we need a number between 1 and 10. So when I look at 5, whatever, 972, the first number that's between 1 and 10 is 5. So I'm going to take my decimal point, which is at the end of the number, because if there's not a number there, it's at the end. And I'm going to move it all the way up so it's after the first non-zero digit. So now my number is 5.972. Now that's obviously a completely different number than the one above it, so I have to make it mathematically equal. So if you remember back to elementary school, you learned the tens times tables. So you had 2 times 10, and your teacher told you just to add 0, and 3 times 10, and you had 30. Well, then you got older and they started multiplying decimals by 10. Well, you didn't add a 0. What you actually did is move the decimal point over one place to the right. It got bigger. And then if you took 1.5 and you times it by 100, it moved it 2 places. So we're going to do that same thing. We're going to multiply this number here by all of these zeros here. so that it equals the same really big number. But I don't want to have to write out whatever this really big number is. So I don't want to have to write out 5.972 times all of that. So that's where this part comes in, the 10 times exponent. So we're going to say 5.972 times 10, and every time we times it by 10, we move the decimal point one place to the right. So if it's here and I want to get it back to where it belongs, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 spaces. So really, I'm multiplying 5.972 times 1 with the 24 zeros after it. But I'm not writing those. I'm using my exponent to show that. So this is that really big number in scientific notation. As you can see, it's so much easier to write. So let's talk about Jupiter. So Jupiter, this is the distance. Ooh, it jumped. This is the distance it is from the sun. So this is a little bit more manageable of a number. But I wanted you to see that really big number. So again, we're going to get a number between 1 and 10. So we're going to find our decimal point. Sometimes your decimal point's in the number. If not, it's always at the end. So I find my decimal point and I move it so that it's after the first non-zero digit. So it's going to be 4 point. Now you have to write all those non-zero digits. 838. And when you get into science, you'll talk about significant digits. Well, everything that's not zero is significant. So here we have to write it down. Now we're going to do times 10, always times 10. You can tell in numbers in scientific notation because it says times 10. And then remember, it's the number of spaces we moved to the decimal point. So the decimal point is here. If we wanted to get the number back to its original form, we would have to multiply it by 10. 1, 2, 3, 4, 5, 6, 7, 8 times. So that's the number in scientific notation. Now, can you go from scientific notation back to standard form? I kind of sometimes think this is easier. So if I'm timesing it by 10, it's going to get bigger. And for the number to get bigger, I have to move the decimal point to the right. So what I like to do is I like to start off with like 1, 2, 3. How many places do I get to the very end? So I have 1, and then my decimal point was there, and now I go 1, 2, 3, and then I just count up the rest of the zeros. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then to make your life easier, go back and put in your commas. So a supercomputer can perform that many operations per second. That is quite the computer. Now let's look at the next one. I would suggest you stop the video, try this, and then play it to see if it's correct. So again, on this one, I'm moving the decimal point 6 times. This is the moon's diameter, so I'm going to move it over 1, 2, 3. So that's 3, 1, 2, 3, and then the rest are zeros, 4, 5, 6. And that's in meters. Okay, when writing really large numbers in scientific notation, this is important. You're only talking about really large numbers. So if you're really big numbers, how do you determine the value of the exponent? Well, if you remember, it's the number of spaces you move the decimal point. It is not the number of zeros. I'm going to write that. Not the number of zeros, because that is the most common mistake that students make, is they write down that it's the number of zeros. So if we go back and look, this number here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros. But if I wrote it times 10 to the 11th, my decimal point would only end up here. And I need it to be after the 1. So you could check yourself by going backwards. Just remember that it's not the number of zeros. Okay, so this is Avogadro, and he created the mole. And the mole is the number of particles in a given substance, and it's equal to all of those zeros, 1,1,1,6,6,0,5,4 atoms. So if you were using this in your calculations, it would be a fate worse than death to have to write out all of those zeros. So we definitely use scientific notation for Avogadro's number. In fact, we memorize it in scientific notation. Now the difference is that if you notice, we're moving the decimal point. The decimal point's already in my problem. It's here. And I have to get it to the first non-zero digit. So if I look, it's zeros, all these zeros, all these zeros, all these zeros to there. So now my decimal point is going to be 1.66054 times 10. But if I multiply it by the number of times it's 0, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's 27 times. Now, if you notice, if I took 1.66054 and I times it by 10 to the 27th, I'm going to end up moving my decimal point to the right, which means my number is getting bigger, which is not at all what I want. So to show the numbers getting smaller, you're actually going to divide. And to show division, we use a negative. And if you remember from the chart that we did with the base to the 0 exponent, then the negatives start turning into fractions. So remember, you're dividing. So instead of when you have really small numbers, you have to remember that it is going to be a negative exponent. So keep that in mind. Positive, big numbers, negative, small numbers. So this is a small number. And we're going to write it in scientific notation. So we're taking our decimal point and we're moving it after the first non-zero digit. So it's going to be 5.9 times 10. And then how many spaces did you move the decimal point? 1, 2, 3, 4, 5, 6. Again, remember, it's the number of spaces you move it, not the number of zeros. And it's less than 1, so this has to be negative. Okay, now let's go back to standard form. So we wrote it in scientific notation. Now we're going to write it in standard form. So you have to remember this is a -3. So you're moving to the left. Your number has to get smaller. You're dividing, however you remember it. So I'm going to take my number 486. And if I think about it, I'm moving it at 1, 2, 3. So there's going to be 2 zeros in front of it. And I actually always take my decimal point and start moving it, and then I just fill in the zeros and the spaces. All right, another problem you might see is something that looks like this. A calculator displays 8.3322 EE8 as your answer. All this is this part here is your exponent. So the 8.3322, that's in scientific notation because the decimal point is after the first non-zero digit. And instead of the EE, you're going to put times 10 to the 8th. So just remember that is your times 10. So if I wanted to try one on my own, and maybe you want to pause the video and then come back, we would first write this in scientific notation. So remember, we're moving it to after the first non-zero digit. So we have 4.65 times 10, and then it's how many spaces you moved it. 1, 2, 3, 4, 5. But it would be negative because it's small. So the calculator would write 4.65 EE, no 10, and then -5. Okay, so I hope that helps you write numbers in scientific notation. Remember, positive numbers or positive exponents, the numbers are getting bigger, and negative exponents are getting smaller. And the exponent is the number of times you move the decimal point, not the number of zeros. Now take a look at these questions. Your teacher's going to ask you